Okay, so basically we're doing the same thing using what we know about converting radians to degrees and degrees to radians, but now we're going to do some applications of more problems. So on this first one, I'm going to get you kind of started. So the minute hand of a clock is 8 inches long. So basically that's going to be your radius. And so what they want us to do for each one is find the distance, and most of them I think are in terms of radians. I don't know. I think it's also in as a decimal. So the first thing, understand that because it says on this one we want to know the distance that the minute hand would travel for 10 minutes. Well, let's think about that. When I'm thinking about 10 minutes, we know there's 60 minutes in a whole hour, right? And if I go all the way around, okay, use up that 60 minutes, that represents 360 degrees. So you kind of want to know what degrees represents 10 minutes. So I'm going to convert that to degrees, cross multiply, hopefully, I think we get x is 60 degrees. And then I want to know, basically, what measures that in radians, because to find the distance traveled means I'm going to find the arc length, and that is that formula equals the radius times theta, and theta has to be in terms of radians. So basically I'm taking that degrees, the 60 degrees, and I'm going to convert it to radians. So that takes the degrees multiplied by pi over 180, which reduces to 1/3 pi. So I know the radius is 8, and I know now my radians is 1/3 pi. I'm literally just going to say, and I'll write it over here. I probably should have did that in my. The distance traveled, the arc length, is 8 times 1/3 pi. And you can just literally type that into the calculator. To the nearest tenth, I don't think they indicate it, but since we're trying to find distance, we need to go ahead and get a decimal or a whole number answer. And so when I literally type that in, so I have basically 8 times, if I do control divide, that gives me a fraction, 1/3, just a recap. And then we're going to have pi here. And we're going to hit enter, and that's about, sorry about the glare, but about 8.38, okay? So the answer here was 8.38 when you plug it in. Now, on B, they wanted the distance with the minute hand travel for 40.5 minutes. So same thing, we know 40.5 out of the 60 minutes, and then we need to figure out what degrees that is out of 360. So, get your degrees into radians, do the same thing, and then we're going to use the same formula. So I'm not going to do B because B is like A. That's my hint for you. Now, when you get to C, because we are talking about hours now, okay, because we're doing the same thing with distance to the tip of the minute hand travel in 3.25 hours, because we're doing hours now, we need to convert our minutes to hours. So we know that 60 minutes represent 1 hour, so we want to know how many minutes would be in that 3.25. So that's our first step. This is first. So go ahead and do that first. Hopefully you got 195 minutes. So we know that our x, there's a lot of space here. So what we're going to do second is we're going to now come up with the angle, the radians for that. So 195 minutes out of 60 minutes would equal to what degree out of 360 degrees? And that degree is going to be into radians. So we're going to cross multiply there, get that degree, and we're now going to use our formula. I believe when we get our degrees, it's like, I think 6.5 radians. Yeah. So basically we're going to end up, oh, we'll get the degrees, I think it's 1170, yeah. So here are degrees, I'm going to write it underneath here, there's 1170 degrees. But now we have to take that degrees and convert it to radians. So we're just doing what we did before, take that 1170 times it by pi over 180, and then we go back to what we did in the very first step. So once you get that in radians, now we're using our formula radius, which we know is 8 times theta, because this represents our theta once you simplify that. Oops, sorry. So I know it's multiple steps, it's kind of crazy. This next one, because we're trying to figure out, I believe, the minute hand traveled, approximately how many hours that is. Okay, there's no really conversion here. We're just using what we know about a circle. So we know that a circle circumference is 2 pi r. Our radius is 8, so our circumference is 16 pi. We know that it is traveling 100 feet, so we're trying to kind of figure out what, what part of the circle is that in regards to the circumference. So first of all, because my radius was in inches, and I forgot to state that this was inches, let's go ahead and convert this 100 feet into inches by multiply by 12. And then if I want to figure out what part of the circle that is, I'm just basically taking that 1200 and dividing it by my circumference, 16 pi. And that would give me my answer. That is correct, yeah. And then the last one, same relationship. The only difference is now they gave you the degree and they gave you the measure of the central angle in degrees, so convert it to radians like you've been doing. We're going to use the same formula. And our radius actually is the pendulum here, the 0.8 meters. So let's convert that 86 and then into radians and then plug it into that formula. I think what you need to kind of understand is, that circle is kind of continued around on this next part. And because we know that the distance from the center of Earth to the equator is this 3960, that represents the radius, really. So if I was to draw another one, which is our radius, that would be the 39. I don't know if you can see that, but I'll draw another one over here. 3960. That's the radius. So they've given us our angle in degrees. You need to convert it to radians like you did before, and then plug it into your formula using r times theta, which is in terms of radians. So basically, okay, let me just do this. 12 degrees, 12 times pi over 180 gets reduced to 1/15, pi radians. Right, so we're just going to keep this in terms of pi. That is our theta. And then we're going to take that and multiply it by our 3960. And that will give us our answer. That would give us basically our answer for A. Okay? And then how far apart, oh no, that's how far, that's our B, sorry. That's how far apart it is between the islands. So that was the B. This, in terms of radians, that's the A. Sorry about that. And then 27 is yours. All right, thank you.